All right, we're on lessons 6.1, 6.2, 6.3's review packet. I'll run through this real quick. Starting with number 1, we're going to make a line graph based on the age and weight of this person's golden retriever. Now, whenever we make a graph, we want time to go across the bottom if it's an option. So we're going to put age, which is being expressed in weeks, across the bottom. We got to get all the way up to 24. So if you count it out, there's actually 12 of these. So if you count by 2s, we will get up to 24. So if this is 0, this would be 2. So this is 4. This is 6. So this is 8, 10, 12, 14, 16, 18, 20, 22, 24. So you don't have to label every single one, but you still need to count every single one. And going up, I need to get all the way to 45. And I'm going to count by 4s. So 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48. And now all I got to do is plot these on it. So when the age is 8, we're going to go up to 10, which is going to be, you got to look, this is 8 and this is 12, so it's going to be right in between it. And then 12 and 16, so from 12 go all the way up. 16 has a line right on it. 16 and 27, follow the 16 line up. 27 now, let's see. We're going up by 4s. So here's 24. This would be 28, so 27's got to be right underneath of that. 20 and 39, so 20 is going all the way up. 39 is going to be just under 40. And then 24, all the way up to 45. This is 40, 44, so 45 is right above it. And you'll see this does not make a straight line. And that should be expected if you just look at the numbers. They are not going up consistently. His weight is not consistently going up by the same amount. If it was, that'd form a straight line, but it's not. So it's a little bit staggered like that. So in which time period did Leo have the greater rate of growth? From 16 to 20. So if you look right here, he went from 27 to 39. So he went up 12 pounds. Or from 20 to 24. So from here to here, where he went up 6 pounds. So clearly it's from weeks 16 to 20. What was the rate of change? Rate of change can also be expressed as the slope of his weight from 8 to 12. Now again, remember this is kind of like our x, and this is our y. So if we're finding slope, we can use our slope formula. And the other way to think about it is we're going to find out how much his weight changed per week. That's the rate of change, a rate per weight per week. So from 8 to 12. So we're going from here to here. So we went up 6. The weight, or the y, if you went from 16 minus 10, changed by 6. And it's over the course of 4 weeks. 12 minus 8. So the weight went up 6 pounds in 4 weeks. We want to know what's the weight per week. So you just go ahead and you divide those or simplify it. So 3 over 2 would be the simplified version, which is what you saw in the key. But if you divided it and got 1.5, that would be fine as well. Was the rate of change ever negative? The answer here is no. It says explain. And so you would say the weight never decreased. You would have a negative rate of change if the weight went down or decreased. Okay, to the bottom. So we're showing the number of bushels of corn in thousands produced by 3 states in 3 different years. So finding the rate of change, again, when you see rate of change, think slope from 2002 to 2004. Remember, time is always going to go across the bottom of a graph. That's always going to be your x-axis. So when we subtract our y's on top and our x's on the bottom, you want to put time on the bottom. So we're going from 2002 to 2004. So you'd be subtracting those two numbers. So of course, This equals 2 years. So whatever the change was, we're going to divide it by 2 to find out how much it was per year, the rate of change. And so you're going to go ahead and you're going to drop this and this in, and you're going to subtract them. Okay, and so we're going to get that number right there. So that was the amount it changed over 2 years. If we want the rate per year, we're going to divide that by the number of years, which was 2. And so it's 156,425. And again, that's per year. Which state had the greatest rate of change from 2002 to 2004? So from here to here, which one changed the most? So we just figured out Iowa changed by 312,850. We'd have to subtract the rest of these and find out what it was. So this one changed by 616,500. And when I look at this one, that one merely went up about 100,000, a little bit more than 100,000. So clearly the answer, which one had the greatest rate of change, which is basically just asking you which one changed the most over that time period, would be Illinois. So which states had a negative rate of change in production from 2002 to 2003? So from here to here, which one went down? This went down. This went up. So this one went up. And this one went down. And so the negative rate of change comes from a decrease. And so we have two of them. Iowa went from 1.9 to 1.8 million, so they went down. That's a negative rate of change. And Kansas went from 301,000 to 300,000. So Kansas fits that bill as well. Okay, so we're flipping over to 6.2's review. Now we're actually not calling it rate of change anymore. We're going ahead and just saying the slope of the line. So again, slope, subtract your y values, subtract your x values. So on my y's here on top, it's going to be 66 minus 30. And my x values is 5 minus 2. So that looks like it's 3, and this is 36. And if I divide those, I get a nice even 12. Over here, -4 minus 4. And again, you can go whichever direction you want to go. Just be consistent. So I'm going this direction with both my y's and my x's. So -4 minus 4, 8 minus -8. So that's going to go plus plus. So -4 minus 4 is -8. This goes plus plus, and I'm going to get 16. So I have a negative slope, and 8 over 16 is going to simplify down to 1/2. Okay, now we're finding the slope on the graph. So first of all, you should think positive and negative. So m is going down, that's a negative slope from left to right, and n is going up from left to right. This is a positive slope. Now you can just deal with how much up and down, how much over. Now you need to be careful on this one because the graph's counting by 2s, so you can't just count boxes, okay, because every box is worth 2. So starting with, well, I guess we'll start with m here. So m is going from this point to this point. So we need this measurement. So that looks like it's down 4 because it's 2, 4. These lines are worth 2. And also over 4. So if you wanted to start with -4 over 4, that's fine, but that will reduce to -1. Down 1 over 1, down 1 over 1. Line n is a different color. It's going up from here to here and then all the way over. So this is 1 to get to the line, and then another 2, so that's 3, and then another 2, so that's 5 up, and then over. If I go from 0 to here, this is at 7, so from here to here is 7 plus another 1 because it's in between, and so that's 8. So this is an up 5 over 8. All right, we skipped number 5. This type of question is important, but specifically they chose numbers that kind of come out weird and deal with some fractions that goes a little bit more in depth than we need to go right now. So we're skipping number 5. Number 6, Okay, an equation will give you the slope if it's in y equals mx plus b form. That's your slope, that's your intercept. This is slope-intercept form. And if they give you an equation that's not in that form, we got to get it there. So we're going to start off with 3x plus 4y equals 16. And we have to get y by itself. And then whatever the coefficient is of x, that's your slope. So I'm going to minus 3x, y, because here's my y, and I want to get everything away from it. So 3x has got to go and 4 has got to go, and then it'll say y equals. So I'm going to minus 3x. So it's gone. So I'm left with 4y equals. Now on this side, if you want to write 16 minus 3x, that's fine. You can't put them together. One has an x, one does not. I'm going to go ahead and put my minus 3x, so negative 3x up front, just because that's the form I'm used to seeing, but you don't have to do that. And then this is a positive 16, so it would be plus 16. So my slope right now is affected by this negative 3, but that's not it yet, because I still have this 4. Until y is completely isolated by itself here, that is not the slope. So I need to divide by 4. Everything gets divided by 4. So this clears out. Negative 3 and 4, if you want to get the decimal, that's fine, but I'm going to leave it as negative 3/4 x. And then plus, and 16 divided by 4 is 4. But that, in this case, is not relevant. All we're looking for is the slope, which you will find as the coefficient to x, so that's negative 3/4. Okay, number 7. They give you 2 points, and they're given to you as variables. They tell you a does not equal r. Why is that important? Because those are your x values. If they were equal to each other, if it was the same number, it would go on the bottom of your slope, right? x2 minus x1. And so if they were the same number, any number minus itself is going to be 0, and this would create an undefined situation. So they're telling you it's not undefined. It's going to give you an actual number. So what's the slope? So all they want you to do is plug into this equation. You can't do anything with the letters, obviously. You can't subtract a letter. So we're just plugging it in, and we're going to leave it there. And so traditionally, this would be y2, and this would be y1. So I'm going to take y2, which is s, minus y1, which is b. And on the bottom, I'm going to take x2, which is r, minus x1, which is a. And if you had those reversed, that's perfectly fine. You can do b minus s, but if you're going to go that direction with the b and the s, then you have to do a minus r on the bottom. Both of those are fine. Okay, just be consistent. All right, just really testing positive, negative, undefined, 0 slopes. So positive slope is going up from left to right. So that would be letter R. It would also be letter T. Those are the only ones from left to right that increase. Negative slope is going down. That's only letter P, going down. 0 slope does not go up, does not go down. So that's Q and S. Which line has the greatest slope? So if we knew the numbers, which one would have the biggest numbers? So that would be the steepest line. It's going up the fastest. So when you look at R and T, okay, T is a little steeper. It's going up faster. So that is going to have the greater slope. Which line could have the equation y equals negative 3? So going back to a couple chapters ago, when you have a y equals, that means the y value is always negative 3. The y value is not changing, so it's going to be a horizontal line that hits the y axis. So we've got 2 of those, Q and S. Either one of these would be a y equals form equation, but only one of them is going to produce a negative number. So this could be y equals negative 3, and so the answer is S. Y would produce some kind of positive number. Okay, so the answer there is just S. Okay, so now 6.3. As you move 1 unit down to the right on a line, and we're dealing with a slope of negative 6, in which other direction do you also move? So since it's negative, so first of all, this slope, negative 6, is down 6 over 1. It's always left to right. So as you move 1 unit to the right, which is this, in what other direction do you also move? Down, because it's negative. How many units? 6. Okay, totally separate from that now. Give an example of 2 points that lie on the same horizontal line. Okay, a line like this. So on any horizontal line, if this was on a graph, right, if it's on a graph, that horizontal line in blue right there, the x value changes as I slide around this. Negative x's, positive x's, here's 0. But the y value doesn't change. It doesn't go up or down. So you can pick any 2 points that have the same y value. I'm going to go ahead and keep it positive. So I'm going to just randomly think of numbers that could be up here somewhere. So maybe this is an x value of 1 and a y value of 4. And then what about this one? Maybe that's an x value now of 5. The y value hasn't changed. It would still be 4. So when you're checking your answers, as long as your y values are exactly the same, you're good. Your x values would then be different. So now, question 4, use the points from question 3, so the ones that you came up with, to explain why the slope of a horizontal line is 0. So we're going to show that if we go ahead and find the slope of these points and our y value is the same, that produces a slope of 0. So when I subtract my y's on top, there's my 0. 0 on top is okay. It's not going to be undefined. And on the bottom, I had 5 minus 1, so that's 4. So that equals 0. Okay, so I've explained why a horizontal line has a slope of 0. So give an example of 2 points that lie on the same vertical line, so up and down. So if you put this one on a graph, you can see on this line, the x value never changes. We're not going left, we're not going right. That x value, whatever it is, 1, 2, let's call it 3, never changes. So I go up here, the x value is 3. I go down here, the x value is 3. The y value increases, the y value decreases, but x is the same. So I'm going to call that 3. I'll go ahead and just use that point that I already have right there. That would be 3, 0. And let's say I had a point up here somewhere. It would still be 3, and then whatever you want to call it up there, let's call it 7. Again, checking your answers, your x values need to be the same number if it's a vertical line. The y values would be changing. So similar to what we just did, we're going to use these points that we chose in question 5 to explain why the slope of a vertical line is undefined. So going back to our slope formula, if we subtract our y's, I have 7 minus 0. So again, I chose to go this direction. And then subtracting my x's, 3 minus 3. So that's going to produce a 0 in the denominator, which is going to make it undefined. And I got a 7 up top. But anything divided by 0 is undefined. Okay, number 7. Installing a washing machine. They had to move it out of the basement. To do this, they build a small ramp. They lay a piece of wood over the 5 steps. If the rise of each step was 6 inches, so first of all, we've got steps going down. Okay, and then you've got this piece of plywood that's just being laid down as a ramp down your stairs. And they tell you the rise or the vertical part of each step. So this part right here, the up and down, was 6. And the run or the horizontal part, this, was 9. What's the slope of the ramp? So you could go ahead and calculate it for 5 steps, but remember that we'll always simplify back to just 1 step because the slope of each step is not different. They're all the same. So whether you measure all 5 at once or just one individually, they will give you the same slope. The 5 steps will give you bigger numbers, which will simplify down. So we can just work with 1. So first of all, the slope of these steps, the rise and the run, is 6 and 9. And they're moving it out of their basement. So they are going up. So we're going to assume we're going up the stairs. And so we'll give this a positive slope. If you're going down the stairs, you'd call it a negative slope. So we're going up the stairs, positive slope, 6 over 9. That does simplify down to 2 over 3. And again, if you had done that for 5 steps, you would have to say, okay, well, a decrease 6 5 times. So that would be 30. And then 9 5 times. And that would be, hold on. So 9 times 5, that would be 45. Sorry about that. And this would also simplify. You'd be dividing by 15. It would simplify down to 2/3. But again, you can see, started to make mistakes because we're dealing with bigger numbers. We might as well just deal with 1 step. The slope is consistent. It's not randomly going to get steeper or flatter. Every single stair is the same. So it doesn't matter where you measure the slope, it's always going to simplify down to the same answer. All right, number 8. We're just going to go ahead and graph these lines. So we're starting at this point using this slope. Now, these graphs are a little tricky because they're counting by 2s, so we do need to be careful. So 3, 1, this is my x and my y. So on my x-axis, I'm going to 3, which is between 2 and 4, and my y is 1, which is between 0 and 2. So that's the point 3, 1. Has a slope of -2, so going down 2 over 1, not boxes, but actual units. So I can't go down 2 boxes and over 1, 2 boxes and over 1. It's 2 units. So if I'm at 1, I go down 1 to get to 0, I go down another 1 to get to -1. So I've gone down 2 now, which is what I want to do. And then always to the right, over 1, I was at 3, and now I'm going to be at 4. Down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Okay, my line looks like that. So it just made tricky because the graph doesn't count by ones. Be careful. Okay, same idea here. -1, -1 is going to be right here floating in the middle because that's -2, that's -2, so -1 is right in between. Has a slope of 1, 3, so we're going up 1 because it's positive over 3. So from here, up 1 puts us back on the x-axis. Over 3, here's 1, 2, 3. So if you're counting by ones, you got to go half a box. So up 1, and then over 1, 2, 3, up 1, over 1, 2, 3. Okay, and on to the last page. Similar question to what we just completed at the bottom of the last one. So we're going to graph a line with a slope of +7. So that's up 7 over 1. That passes through the point 8, 1. So 8, 1, let's start there. X is 8, y is 1, which is right here. So we are going to go up 7 over 1. So be careful. If you're counting by ones, it's half box. 1, 2, 3, 4, 5, 6, 7, and then over 1 is a half of a box. Just look at the numbers, it should make sense. In terms of going up, our y value was 1. If we went up 7, that puts us at 8. Okay, so that makes sense. If we go in the opposite direction, we're going to go down 7, but kick it to the left. So 1, 2, 3, 4, 5, 6, 7. Continue the line this direction. Okay, we were at +1. If we go down 7, we're at -6. That makes sense. All right, and then down to the bottom, some rate of change questions. What was the rate of change, which again, can't stress enough, is slope, of the cable subscribers from 1980 to 2005. So we're going all the way from here to here. When you go ahead and calculate that rate of change, we don't need any of these middle numbers. We're just going to put an average rate of change, whether it's positive or negative, from the beginning to the end. So we're only looking at those numbers. Remember that years are always your x because you would put that on the graph going left to right so you could see it. So when I go ahead and set up my slope formula with my y's on top and my x's on the bottom, my years are going to go on the bottom. So it's 2005 minus 1980. And I'm not going to write out these really big numbers on top, but you're going to go ahead and subtract this number and this number on top. So from 1980 to 2005, that's 25 years. So I'm going to go ahead and subtract these and see how much it changed over 25 years. And then you divide it by 25 to find out how much it's changing per year. So let's go ahead and subtract. Okay, so I'm not going to write that number down, but this is the amount that it changed. And that's over 25 years. So if we divide this number by 25, you're getting an average of how much it's changing every single year or per year. So divided by 25, and that is 1,934,120 subscribers or people per year. So it didn't go up exactly that much every single year because that's not normal, right? You're not going to have a consistent amount. But on average, from 1980 to 2005, we went up this much per year. So if you took this 25 times, you would get back to the number of people that it increased by. Okay, number 6, during which years was the rate of change the greatest? So what we need to do is actually calculate how much did it go up each year and take a look, but just kind of just eyeing it. So from here to here, that's about 17 million. from here to here, from 34 to 50, that looks like about 16 million. Now, those are close enough that just eyeing it, you might want to go back and check those numbers. But from here to here, that's about 10. From here to here, that's about 6. And then from here to here, it went down. Okay, so clearly it's one of these two. It looks to be 80 to 85, but let's go ahead and double check those numbers just to make sure. So we're just going to subtract and see how much it changed. So first I'm going to subtract 1985's number and 1980's. Okay, and that was 16.9. So let's write that number down. So it changed by about 16 million, almost 17 million. Now the other one, so 1990s, is again over 16, but 16 million and then 80,000. So this one is really close to 16. This one's close to 17. So the initial one right here, 1980 to 85, has the greatest rate of change. Not by much, over 85 to 90, but it does have a greater change, so it's going to have a greater rate of change per year. Okay, number 7, give an example of a time period where the rate was negative. So we said it went down over here. That creates a negative rate of change, so 2000 to 2005. All right, so this was questions 5 to 7, so we're done with that. Now these are separate questions. Give an example of a point that lies on the line with an undefined slope. So undefined slope, straight up and down. So again, if this was on a graph, what's changing? The y value. The x value, if it's undefined slope, does not change. We're not going left or right. So I'm looking at this point. If I'm going to give another point that's on this line, so if we were just going to estimate, 5/8 negative 3, it's somewhere down here. So my x value here, this value, from left to right here, is 5/8. So no matter where else I go on this line, that's not going to change. It's not going to get bigger or smaller. So my x value still has to be 5/8 if I'm on this undefined slope line. But instead of going down 3, maybe I'm up here at positive 5. So any answer here would be good as long as your x value is 5/8 and then your y value is something other than negative 3. All right, and number 9. These types of questions definitely trip people up. So let's go ahead and find this. They're going to give you 2 points, but one of your values is missing, but they are going to give you the slope. So it's like they gave you the answer and you're missing something in the original question. You got to work backwards. So again, y2 minus y1, x2 minus x1 for slope. They're telling you that it comes out to 12 or 12 over 1. But the numbers that are given to us, we've got, I'm going to go this direction. 4 minus y, and 2 minus negative 2. And so if I just simplify what I can't do anything with the top because it's 4 minus y. But on the bottom, this goes plus plus, this is 4. So this has to produce this. So I'm dividing something by 4 and getting 12. So if I go ahead and do 12 times 4, I know that this top part has to be 48 because I'm going to have 48 divided by 4, which is 12. So now I can just look at this top part. 4 minus y has to give me 48. So 4 minus something gives me 48. So if I start with 4 and I subtract something to get a bigger number, clearly this y value is something negative. So it's negative something. It would be 4 minus negative something. So it's going to go plus plus. And 4 plus what gives me 48? That would be 44. So 4 minus negative 44 gives me 48, which when I divide it by 4, it gets me back to the 12. So the answer here is negative 44. Okay, if that reasoning doesn't make sense to you, then what you want to do is once we get this far, we plug this in, we simplify the bottom. We're going to say 4 minus y over 4 equals 12. And what you want to do is you want to just go ahead and you want to solve this. So using our algebra skills, we can just solve this without having to reason through it. We want to clear out the bottom, so we're going to times both sides by 4, which will clear it, leaving me 4 minus y and 48. Then I'm going to minus 4 on both sides, which is going to give me the 44. But I do have a negative y. You must bring that down. And then we know to get rid of that, we divide by negative 1. And when you divide by negative 1, you're going to get negative 44, which is the same answer. So if reasoning through it doesn't work for you, you can always fall back on just solving an equation.